Good afternoon. Today we are working on CO44. I can determine the probability of mutually exclusive and overlapping events. So in order to know how to do those, we need to understand what the words mean. Once we hear the explanation, it's going to get a little bit easier to figure it out. But for right now, let's put calculators down. These are new vocab words for us, so we do need to be paying attention. Lots of doodling is happening. Let's all stop with the doodling. We're going to get back into math. Right? New concepts being introduced. So let's look at what mutually exclusive means. Mutually exclusive are events with outcomes that cannot happen at the same time. For example, there are 3 red, 5 blue, and 8 yellow marbles in a bag. What is the probability of choosing a yellow or a red? This is mutually exclusive because why? Why do you think this is mutually exclusive? Who thinks they could finish this sentence? This is mutually exclusive. Why? Baby?
Because they can't tell me what I need at the same time.
I don't know why mine says red and a blue, but you are correct. You can't pick at the same time. You can't pick 2 different colors because this is mutually exclusive because you can't pick 2 colors at the same time. You can only pick 1 color. Overlapping events are events with outcomes that can happen at the same time. Here's an example for that. An integer is randomly selected from numbers 1 to 20. What is the probability that it will be either odd or a prime number? Can it be both? What would be an example of an odd, that is a prime, that falls between 1 and 20? Fallon? 5. 5 is an odd number. It is a prime number, and it falls between 1 and 20, so it can be both. So this is overlapping. Because if you pick a 5, it is both odd and prime. So if we look at our odd numbers, we know there's 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19, between 1 and 20. There's all those numbers. Our primes would be 2, 3, 5, 7, 11, 13, 17, 19. We have overlaps, more than just the 5. So if we look at the odd numbers and we look at our prime numbers, we need to look at which ones overlap. So we see 3, 5, 7, 11, 13, 17, and 19. Here's the tricky part. You can only count the common outcomes once. Okay, so this is important. You can only count the common outcomes once. So what would our probability be? What is the probability of pulling an odd or a prime? Numbers 1 to 20. What do we know is going to be our bottom number? What is the total possible outcomes? How many possible outcomes do we have if we have numbers 1 to 20 and a half? Robbie? 20. So we know on bottom it's going to be 20. What is our successful outcomes? How many successful outcomes can there be? Valid? 1, 2, 3, 4, 5, 6, 7. So you counted the common ones. But can I pull an odd number that's not a prime? Yeah, because it says, what's the probability of pulling an odd or a prime? So we have to also count the numbers that don't overlap. The ones that overlap, we count one time, and then the ones that don't overlap, we count one time. So if we look at this, we have 1. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 odd numbers. How many primes that are not odd? 1. That 2. So how many possible successful outcomes would there be if we add them all together? Second? 11. I don't know why it's doing this goofy thing for me. So it would be I don't know why it's being goofy. Oh my goodness. I don't know why I can't write at the moment. I'm gonna have to delete the. So half of it deleted, sorry about that, but you have it written down. So if you counted up all of the odds, and then whichever primes did not overlap with the odds, you added to it, but you can't count the 3 times, right? So you counted up the odd numbers, you counted up the primes that didn't overlap, and we ended with 11 possible successful outcomes. Does that make sense? So you don't just count the overlap. You count overlaps, you can only count once. So we counted our prime, or our odds. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we wanted the probability of pulling an odd number, it would be 10 out of 20. We can also pull primes. So that's why we made our list of prime numbers. So there was our list of prime numbers. There was one in that list that was not also in the odds, so we needed to add that one onto it. Everyone else in that list, we've already counted. We can't count it a second time. That making a little more sense. Show me your thoughts. How are we feeling about the overlapping? Okay, so there's a couple of us are still like, I think I get it. We're gonna continue down and see if it really gets in there. So mutually exclusive, only one of them can happen. And overlapping, they overlap. You can have both odd and prime. So let's look, right, whether the event is mutually exclusive or overlapping, so that's the first thing we have to figure out. Then we're gonna find out the probability in fraction form. We do not have to turn it into a percentage. We just need that fraction for our probability. I don't know.
Does it need to be simplified fractions?
Does it always need to be simplified fractions? So let's look at our first one. You have 26 cards, each labeled with a different letter of the alphabet. What is the probability of you choosing a letter in the words SVDP or Royals? So what's the first thing we're going to look at? Because we want to know if it's mutually exclusive or overlapping. What do we have to look for? David,
It's overlapping.
what do we have to look for? How would you know what answer you just gave me? I'm not looking for the answer, I'm asking, what is it that you're looking at?
You look at all the letters and see if there's any overlapping between the
You
two.
see if there's any letters that are the same, right? That's the overlap. So I see there's an S in SVDP and there's an S in Royals. There's an overlap. There's the common letter that they have in common. So we know that it's overlapping. So that was the first thing we were looking for. We know it's overlapping, so we have to write that. Second part is find the probability. What would my fraction look like? Luke, how did you get 9/26, Luke?
Because there's, so there's, in SVP there's 4, and then in the Royals there is 6, but you can only count the extras.
Yeah, so we had 4 right here. We can't count that S because we've already counted an S. So we have 5 with the Royal. So 4 plus 5 is 9. We know that there are 26 cards altogether. That's the total possible outcomes. So that goes on the bottom. So 9 out of 26 is our probability. Can I simplify that?
No.
No. They don't share any factors to divide down. So this is my final answer for the probability is 9 out of 26. How are we feeling now about probabilities, mutually exclusive, overlapping? Are we feeling okay? This is a one-pager assignment, so I don't want to do a whole lot together because I want you to practice and see if you totally understand it. So go ahead and work on this. You can ask me if you have questions. But you're going to have to do a little work. Just like with the odd and the prime, we had to list stuff out. You're going to have to, for some of these, list things out to see if it's mutually exclusive or if there's an overlap. So think about from the numbers 1 to 50, what is the probability of choosing a factor of 48? What do you think you're going to have to list out? Factors of 48, right? Don't miss any of them. List them all, otherwise your probability is going to get messed up. First thing you look for is it mutually exclusive or is there overlap? So think it through. Am I listing stuff 2 times? That would be an overlap. We listed the S twice, that's overlap. If you're not listing stuff more than once, there's no overlap, it's mutually exclusive. But make sure you're listing everything that you need to so you can find the correct probability. Any questions? Remember, tomorrow Khan Academy is due. Packet number 7 should be in the blue tray. And you have packet number 8 to work on if you finish. You can always come up and check with me to see if you're doing things correctly. This is quiet work time. If you are watching at home, I hope you are well, and I hope to see you soon. Have a wonderful day.